So before we go over this question, let's just recap a few exponent rules. If you have a base, let's call it x, and you raise that to the a power, and you multiply that to the same base with a different power, we can simply keep the base as it is, and then we would take the two exponents and add them up. Similarly, if you have x to the a, and this time let's say we're dividing that by x to the b, we keep the same base rather, and we subtract the exponent. Finally, if we have the same exponents and the same bases, we can take our pick. So in this case, I'm going to have x to the a times x to the a. Either we can do what we did here up top, and we can keep the base and add the exponents together to get x to the 2a, or we can do the second rule, which is we keep the exponents as is and we multiply the bases together. So we have an x times the x, which gives us x squared. Now the rule when we have a base raised to an exponent and that whole thing raised to another exponent, we multiply these two exponents together, so we get x to the 2a. As you can see, we have x to the 2a here, x to the 2a here. It's really the same thing, we just change the order in which we combine the exponents. So let's take a look at our equation, or the question that we have to simplify. In this case, we have a whole bunch of third roots, and typically I don't like really dealing with third roots, so I'm going to change that right away to a 1/3. And just to clarify, whenever you have, say, the 8th root of x to the b stays with x, and this power of that radical becomes the denominator of the exponent. So to give you an example, if we have the 5th root of 2 to the 3 power, again, the 3 stays with the 2 on top, and the denominator becomes the power of the root. So 2 to the 3/5. Anyway, so going back here, we can either do this the first way that I showed you here, where we combine all the exponents together because the bases are the same. They all have a base of x. Or we can use this rule because the exponents 1/3, 1/3, and 1/3 are all the same. So you can really take your pick. In this case, I'm going to multiply out first. So we have x to the 2/3, x to the 4/3. On the denominator, we have x to the 8/3. From here now, we're going to use this rule where we keep the base and we add the exponents. So we have x to the 2/3 plus 4/3. On the denominator, we have x to the 8/3, which gives us x to the 6/3 divided by x to the 8/3. And finally, we use the second rule where we subtract the exponents since we're dividing. We keep the base as it is, and we have x to the 6/3 minus 8/3 to give us x to the negative 2/3. Since we have a negative exponent, that just means that we have to put it on the denominator. And at this point, we can take a look at our answers. And because our answers aren't in radical form, we have to convert this. So we kind of want to do what I showed you here, where the numerator of that exponent is going to stay with the base, so x squared, and the denominator of that exponent becomes the power of the base, or of the radical. So we have 1 over the cube root of x squared, and that would be answer choice B.